All right, these are our phase change notes. If you want, you can go ahead and put the date here, whatever day you are doing this on. And some of these terms are going to be really familiar, and some of them might be new to you. Let's get this in focus for you. There we go. The first one, melting. All that means is going from a solid to a liquid. So ice to water, solid gold, melting to liquid gold. Next we have freezing. And that is going from a liquid to a solid. Liquid water freezing to ice. Liquid gold freezing to solid gold. Now we have evaporating. And evaporating is liquid getting enough energy so that the particles go to a gas. And depending on the textbook or the teacher, they may use the term vaporize or vaporizing instead of evaporating. Also, you might hear boil. When water boils or hit its boiling point, it evaporates. Condensing is the opposite of that. That is when we have a gas that loses energy, so those particles condense to a liquid. Now here come two terms you might not have heard before. The first is sublimation. And sublimation is when a solid is given so much energy it skips the liquid phase and goes directly to a gas. Like snow, if we have a ton of snow, not all of it melts to a liquid, we'd have flooding. So the sun gives it a ton of energy and a lot of it goes straight to the air. That solid ice, the solid snow, solid water goes to the air as water vapor. Now we have deposition. And this is when a gas loses energy so rapidly that it skips the liquid phase and it goes to a solid. So you would have this gas and then all of a sudden there'd be these little particles settling down as a solid. Now the term thermal energy, we'll use it a lot, thermal energy. When you hear that, you need to think heat. And also when you hear the word temperature. Temperature is just a measure of thermal energy or a measure of heat. Now we'll look at something to organize all these phase changes with energy, and that is a phase change diagram. So we have, as you go up this diagram, there's increasing energy or increasing heat. All right, so we will start the coldest of the coldest ice you could have. And then that ice is going to get warmer and warmer and warmer till it hits a point where it starts to melt. And all the energy is going to go to melt those particles and go from these packed solid particles to energy to break them free into a liquid. Once we have that hot liquid water, cold, because it's ice, very cold liquid water, we're going to warm it up, warm it up, warm it up. It's going to get very hot till it hits its boiling point. It's going to boil and all that energy is going to use to make these liquid particles break free into a gas. And now we have a gas and we're going to heat up the gas. So as I fill this in, we will have, down here is when we have something as a solid. This is a liquid, and this is a gas. And if we are heating up the solid and it becomes a liquid, we call that melting. If we heat up a liquid and it becomes a gas, we call that evaporating or vaporizing. Now, if we cool down the gas and becomes a liquid, that is condensing or condensation. And if we go from a liquid to a solid, that is freezing. And then, like I said before, the weird one, if we jump from a solid directly to a gas, that would be to sublime or sublimate. And then if we cool down drastically from a gas straight to a solid, that would be deposition or deposit. The key that we're going to see, and we need to make a note of, the key takeaway here is that when the phase change is occurring, so we have melting, we have freezing, evaporating, condensating, sublimation, deposition. When it is occurring, the temperature or heat does not change. All the energy is going to reorganize the molecules and the particles. All the energy is working on that. It's not working on increasing the heat of the substance. So when the phase change is occurring, the temperature and the heat does not change. Now we can tie this in to particle diagrams of a solid, liquid, and gas. Because solid, we know, is organized. And yes, they're moving ever so slightly, like they're vibrating in place, but they are organized and packed together. And then the liquid, on the other hand, those are moving around like crazy. They're rolling over each other. And then we have the gas, which definitely much more separation between these particles, more room between them, and they are moving like crazy. That's why I have the arrows. To tie this into what we have previously learned, the solid phase, we would say, is more dense. And yeah, the liquid is still pretty dense. And the gas has a very low density, because density is the measure of how many particles in one area of space.